Hello friends, I'm a cloud solutions architect at Microsoft and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, let's get started with a very interesting technical interview problem. So we are going to solve a very interesting LeetCode problem today called Roman to integer. And if we see some of the popular companies who have already asked this question, there are companies like Amazon, Adobe, Apple, Google, Microsoft, Bloomberg, Facebook, Uber, TikTok, LinkedIn, and Goldman Sachs. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and also a very valid problem. If we understand the problem statement, it's quite simple. We are given a Roman language number and we need to convert into a decimal system integer. Basically, that's what it is asking. Suppose we are given a value that looks like XX. Then in this case, we need to return 20 as the answer because that is what it means in the normal decimal system. Suppose we are given the value of like we need to return 3 as the answer because 3 is what represents as III in the Roman numericals. Now we are given a very extensive definition that what every single symbol means and the Roman to its subsequent value, and also what are the different symbols and what are the rules of the Roman language. Now these things are pretty easy to comprehend. There is only a little bit complication when this condition comes in, where it says that suppose a smaller value is placed right before the larger value. In that case, we need to make a subtraction. So I in this case means 1. I is a smaller value and V is a bigger value, which means 5. Now typically, if we put any values like Vi, what we are going to do is we take the value of V, so which is 5, and we take the value of I, which is 1. So 5 plus 1, it is 6. So we need to return 6 as the answer. But the thing is, when we are in a condition where the smaller value comes before the larger value, so say for an example IV, this is one of those scenarios. So in this case, actually we are going to subtract the value of I from the larger value, and that is how Roman numerical works. So in this case, the answer is going to be 5 minus 1, so 4. 4 is what we need to return, and there are 6 such cases where these numbers can happen. These 6 cases are, so these are 6 new values that we have been able to identify based on the rule of a smaller value being placed exactly before the larger value. Okay, so I have drawn the value conversion table over here, and now first we will try to understand that how does a numeric system work in the decimal formula. Suppose we are given a value like 1521. How does this value is being generated? Well, this is a decimal format. So in the decimal format, the value is being generated by 10 to the power of whatever the number of values that are present after it, and multiplied by that particular value. So let me explain to you that how does this value has been formed. This value has been formed by doing multiplication of 1 multiplied by 10 to the power of 3, because there are 3 values present after 1, plus 5 multiplied by 10 to the power 2. So if we do sum of these two, we get the answer of 1000 plus 500 plus 20 and plus 1. And sum of all of these is actually leads us to the value of 1521. And this is how this value has been actually broken down. Now in this case, if we see, the largest value is always presented first, then the second largest value, then the third largest value, and then the smallest value. And this is how the numeric system works. Same logic applies to the Roman integer for the most of the parts. And the logic is quite simple. So suppose in the input, we are given the value of, how do we know that what integer does this value represent? Well, the answer is quite simple. All we will have to do is, we will have to see in this table, fetch its value, and then keep adding the values by itself. So in this case, okay, this M is represented by 1000. Then this D is represented by 500. Then we have X and X. So we know X means 10 plus another X means 10 and plus I means 1. So if we do sum of all of these values, the answer we get is 1521. And this is how this value is being represented. So this seems pretty trivial so far. No issues with this. And also this is also following the methodology where the largest value is present before its small value and before its small value. The problem comes when we have to deal with these 6 items. So let me also draw these ones as well. Okay. Now suppose we are given this as an input, and these are the values that are anomalies in the Roman integer system. These are the values that operate in the same way as the decimal system operates, but when we have a smaller value, so in this case, if you look closely, okay, m is the greatest value and that is why it is presided at the first. D is second greatest and it is presided at the second value. But the thing is, in this case, x is actually a smaller value because x means 10, meanwhile L means 50. So in this case, though x is a smaller value, it comes before L, which means we will have to do a subtraction in this case between these two values and addition with all the values before that. So in this case, let's see what is going to be the answer. So this is going to be m is going to be 1000, then same way this d is going to be 500. That is okay. But when this x and L comes, so basically now what we will have to do is we will have to do minus 10 plus 50. So in this case, the answer is going to be 1540, and this is how we need to represent. So the logic is actually quite simple in this case if we try to understand. What we can simply do is we can simply create a hash map with all of these values combined in a single hash map, and this is going to be the key, and its subsequent values are going to be the values. Now every single time whatever the input we are given, the logic we are going to follow is quite easy. Okay, so for an example, this is the input we are given. Now let's see that using these as the hash map, how we are going to solve this problem. The idea is every single time we will take two values. So in this case, okay, these are the two values. We will try to see that whether they are present as keys inside our hash map or not. If they are present, we directly take its value. If they are not present, we break them down and individually take their values and do addition, and keep doing that till we find the answer. So in this case, first we will try to see that, okay, first two values are MD. Is MD present as an input? No, MD is not present as an input, which means we will have to take M and D separately. So first we will take M. So M's value is 1000 and plus we will take D. D's value is 500. So now, okay, we have taken care of these two values. Now again, we will keep on repeating the same process. So in this case, okay, we will take these two XL as 1. So is XL present? Yes, XL is present over here and its value is 40. So we can directly add 40 over here in this case for this XL and directly jump to this I. So okay, once this is done, now we are again at this IX. So again, we directly try to see that whether IX is present or not. So IX is present. Awesome. Good for us. So in this case, we can directly take 9. And now we do not have any more values to iterate over inside our input. So we can actually just do sum of all of these values and return as the answer. So in this case, the answer is going to be 1549. And this is the whole logic behind our operations. So see, if we just create a hash map with all the possible values, it becomes quite simple for us to solve this problem. And that is why this is a LeetCode easy problem. If we see time complexity, in this case, the time complexity is actually going to be big O of n, there where n is the length of all the values inside the Roman integers. But the thing is, in this case, the input we are given a finite number. So because it is a finite number, it is a finite time to calculate that. So that's why I'm putting the time as constant. And even in terms of space complexity, apart from using a couple of variables, we don't have to use anything. So this is also going to be constant. First of all, we are going to initialize our static hash map and assign all of the values we mentioned. After having all the values, we will start implementing the Roman to integer method. So first we are going to assign some variables. So first variable is sum. The initial value is going to be 0, and we are also going to have an I to iterate over the given input, and initial value is also going to be 0. Now we are going to run a while loop. First thing we are going to check is that if the given I, if is still less than string dot length minus 1. Basically, we will first try to check that whether the given string for two values, does its value exist or not. So now we will check that if this two symbol strings, if that is present inside our hash map, we are going to add the value of sum. And also we are going to update the value of I by values of 2. because we are already taking consideration of two values, and then we will move on to the next value inside our loop. And say for example, for some reason that is not the case, in that case all we will have to do is we simply need to add one value. So once our loop ends, we should have our answer populated in the sum variable, so we can simply return sum. And now let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, and it is also very efficient in terms of time complexity and space complexity. So I would be posting the solution in the comments, so you can check it out from there. Thank you.